Hello everyone, it's Caller from 19. Today's day 65 in my challenge day. And in the last video, I just got to know that there was some camera issue in my iPhone. Just I used my iPhone as a webcam, but there was some kind of delay that um, it seems that I speak so fast and the video's frames does not follow my speaking. So I just changed my camera as my mm, laptop cam. And after the finishing the recording, I found the issue that I occurred. Uh, let's see together. Right. So if you see this, I created a wiki right Descriptor set acceleration structure with a shared pointer. So I thought that if I initialize this string with the shared pointer, it this pnext will increase the reference count. So even though I goes up this local scope, I expect that the resource will alive until the update descriptor set is called. But that that was actually totally wrong. So even though I increase the reference count, because this um, descriptor shared pointer is going to out of scope. So it's just destructed automatically. So what I should to do is make a new members and insert it temporarily, just keeping the memory of the shared pointer resource. And then after I calling the update, I can just clear the temporary shared pointer reference counting. So with just slight modification, I could just resolve this issue. So if you see that, you see that there is no problem. Yeah, as you can see, there is no problem anymore. But I should resolve this issue. So okay, let's start. descriptor set layout is not destroyed before. So I'm creating a new descriptor set layout in my graphics pipeline. Okay, wait. I'm just creating in the ray tracer, not the graphics pipeline. So if we go inside, um, let's visualize ray tracing descriptor set. Let's see. Okay, create descriptor set layouts. So layout is not this document. Let's see how I do that. See the texture. Users use and what? Mhm. Have it here. Yeah, pipeline layout created full. Just said layouts. So within the descriptor of it, oh, feature resource. Yes, I found it here. So I'm creating the FreeK ray tracing descriptor layout in the initial library ray tracing tracing descriptor set. I didn't destroy in the destructor of these ray tracing objects. So let's delete this in here. After destroy acceleration structures, no, let's destroy layout first. This is VK destroy. Descriptor set layout. Add a load. Okay. So this layout has hold two binding for uh, the one the one is for top level acceleration structure and the other is for what was for about it? Yeah, storage image to for the ray tracing output. So when it destroyed the descriptor cell layout, it also free the two bindings from the descriptor set. And the descriptor set, as I mentioned before, it is just automatically destroyed with the descriptor pool, and descriptor pool is destroyed in the descriptor manager CVP. So everything's okay. And let's try build. We run it. What is this? They like that people said acceleration structure can ensure P acceleration structures. So yes. What about giving this as const pointer? Yes, right. With your structure. Perfect. No validation error anymore, and no exception, and no debug assertion error. And okay, let's proceed. Finally, the ray tracing pipeline. Okay. Free shader must be available for execution at any time. It's the shader executed selected on the device at every time. There's two sections to assemble shader by the table. So the first, uh, like the traditional restoration graphics pipeline, we cannot group the draws by material. So it said every shader must be available for execution at any time when ray tracing. So when we do ray tracing, we don't know when it hits and when uh, the the materials updates need to occur at exact time. We don't know that. We can't know that. So the shaders executed or selected on the device at runtime. So it means that we can unlikely the restoration pipeline. In the restoration pipeline, we set up some all of the stages and the layouts and informations in advance. If you know about the Vulkan, uh, you can see that there is some kind of stages like vertex shader stage, fragment shader stage, and input assembly and dynamic states, a rasterizer, vertex sampling, depth stencil, and color blend, and the pipeline layout. Uh, these layout combine all together these whole separate stages in the one steps. So it occurs. I mean, the layout pipeline is created at the compile time. But in regard to ray tracing, we need to do it at runtime. So we need some kind of binding table about the shader. So it called as a shader binding table. The C++ we table, except that we have to deal with ourselves. This knowledge and information that this shader from so the MV tutorial gained a abstracting the shader binding table creation. So let's just see that in the kernel scripts tutorial. Yeah, we have shader by table here. Shader SBT entry. There. Shader binding table. So the ray tracing shader has some different file format, but actually GLSL doesn't have any specific extension format, but it just to clear it, what uh, which the purpose of this shader is used. So it just adds some argent, arnis, and r hit in the ray tracing, the GLSL shader. The point of progress is making research. Establish a color-calling relationship between shadows during switching location. Please. It's publicly copy at least be clear. So if you're familiar to ray tracing concept, you might know that ray tracing is a recursive algorithm. So whenever we call some a recursive function in a certain scope, it's the callee of the function. No, it's a caller, and the callee uh, taking the ray tracing payload from the caller hold the local copy of the ray trace payload in the current state. The caller can select one of its payload to be made visible to the Kali shader. So it said that the caller can select one of its payload. So it means that caller has some series of payload and to be made visible to the Kali. So when it call the Kali, it can select some a specific payload among the payloads that it has. So as it payload in external variable, it's known as incoming payload. The extra shader type should be used. Turn the single colors to the pay payload. So Miss Shader is good when there is no heat between the geometries and the current ray at all. So it can return some base color. Like if we abstract the room as a black, we if there is no light source, it's triggered that the room will be black. So we may can set some base color as a 000, which is RSB code correspond to the black color. So in this case, we can just return the black color to make it as black. I mean that it is not very heat. The closest is shader. It's called the heating the geometry instance. Heating the geometric instance closest to the start point. Right. So what does mean that? Uh, so array compute direction based on is the camera lens model starting point and the pixel number, which is the ray is shooted forward. So if we have this uh, camera point, and if we want to shoot the ray to this pixel, it calculates this direction and it shoot the ray. But the ray is infinite length of the line, so it goes into the forever as much as it can go to, um, and it can hit any geometry on the line. So maybe there can be some cube at the closest point, and the farther point there can be a circle or the sphere, and so on. The closest heat shader basically do uh, the detect the closest point of heating point from the starting point of the ray, and it does There can be velocity shaders and even also like how restoration categories and for lighting ventilation. It's really was like how a restoration-based application has multiple pixel shaders depending on these objects. Two more shader types can optionally be used: intersection shader. So these mist shader and velocity shader and the region shader is a necessary shaders when we use the ray tracing pipeline extension. And these intersection and any hit shader is just optional. Let's just skimming through that. Intersection shader, user defined geometry, right? Without tessellation, then beforehand. Built-in rate triangle notification test for the provide extension. Which returns to flow from the virus representing the data centering point. So ray tracing uh, extension has built-in ray triangle extension. So if you're curious about the ray triangle intersection, I will just explain those shortly. So what's that? So in the traditional ray tracing software, it has the triangle is contained in the quad that holds the quad and it means the plane. So we may can uh, calculate the intersection force between the ray and the plane. And if there is an intersection, then we can just do some intersection check between ray and the triangle. Sorry. Sorry, I just forgot about the how the ray triangle intersection, but there was some kind of dot product logic between the to check the ray triangle intersection. Uh, I'll explain that after I just recap the parts. So intersection shader is required for some usually defined geometry, and so they can be there can be some procedural sphere creation, like based on the some mathematic formula with the Bezier curve or spline curve and so on. And we need to set some user-defined intersection for this geometry. And what is this initiator schematic? It's potential intersection. It's the path through returning this traverse. flag while building a data acceleration structure. Searching for any point close into a version so that can be way and the shader can frequently be used so shouldn't be trusted. So when we searching for the hit point closest to the ray origin, use this closest hit shader, we may can uh, encounter some several candidates may be found on the way. As I said, there can be a triangle, or the further point, there can be a cube or a quad, a sphere, and so on. So we need to test everything to check the distance between the ray shooting point, hitting point, and the location of exact of geometric instance. So in any heat shader can be useful in the case to test like alpha tests. But if we set the opaque flag or beating the acceleration structure, it never will be invoked. So we start the matrix pipeline containing the three main shader programs: region shader, this shader, single hit group, velocity shader. Compute this to y first, shader first bar B. Okay, this is a basic. This was a basic overview for ray tracing pipeline and how we can create it, and which shader type there exists. So it seems that now finally we can looking into the exact details of ray tracing extension in the Vulkan API. So I'm really interested. I'm really excited to uh, dig into these topics. So this is all for today's recording, and as always, thanks for watching, and see you next video. Bye bye.